In this video we are finally create a way to check and rebuild the geological model during tunnel build, tunnel boring machine excavation. So we are make a quickly fast QC analysis for UC model versus for Plaxis model versus the measured model, and we can have some expectation. For example, in the UC model and the UC measure, we have the acceptable range, and you can use this, for example, the water table risk. You can have a plot. This is a simple model. The input data you can use, for example, is starting from the geological model, the predicted geological model that is built from the West Insight drilling data and the geotechnical parameters or the geophysical data acquisition. So you are need to put and verify during the tunnel boring machine excavation. We underline with this gray color the acceptable range, the change between the UC model and the measured model. In this case, we have also to plot the water risk, the risk to meet the water tables. In this case, the water tables is that and the minimum clearance. You have also the quote correction to stay in siltstone and avoid water tables. The water table risk is to do that, so the quote correction is to stay in siltstone and avoid the water table. You have a water table, the current tunnel axis and the corrected axis. So this is a clear way to make a correction between when you start drilling with the TBM. You need to correct the quote from the subsurface and also correct instantly the quote to avoid, for example, the presence of water table. Every check and adjust the geological model, refine the geological and technical model. So we have a QC summary. We have finally the UC deviation expected is around 26 meters, is very high. So the water risk zone, and we have some recommended action. Review geological model with the UC deviation because it is measured than 6 megapascal. Apply quote correction where there is no siltstone. In this case, you have the following you have the following situation with water table in this case that we can change in different periods of years. So you need to avoid this part of water table, so you need a small deviation here. And so this is the clay and the other materials. Finally, you can also create with this simple way. With this simple way, you can create using NumPy, Matplotlib, and Lind Basic. We have the TBM behavior indicators, and with the longitudinal risk zoning plot, you have the TBM excavation risk zone longitudinal profile. You can have the longitudinal profile. Along the longitudinal profile, you can mapping the zone that we can create an alert during excavation. For the green zone, in this case with the green zone, they represent a stable zone with the risk index minus than 0.3. For the amber zone, you have an increase of attention, the risk is around 0.6, and for the red zone is a high risk. So in this case, the red zone represented this part. This part have a critical condition of stability for water presence, for intersection of water tables. So you need to put attention in this part and in all of part, starting from these points to essentially to this part is around 1 kilometers. So it's around 1 kilometers starting from 3.5 kilometers. And you have the amber zone. So we have the construction control guidance for, in this case, we have the risk zone summary expressed in meters. You have around for the amber zone 116 meters in amber zone, for red zone and in green zone. So this is a clear representation of along the TBM, a cross plot along with the TBM tracer, along the TBM tracer, the excavation, along the TBM tracer excavation, mapping the risk and the presence of water table of cavity. We can also mapping the cavity and instability. Thanks for attention.